If new studies into soil properties are to be believed, then everything we've known about soil organic matter and humus are false. And in fact, their role in the modern climate crisis and sequestering carbon are in fact a sham. Join me in this video and I'll talk you through what's being said and what this might mean for how and what you do to your own soil. A few weeks ago, I came across a tweet posted by my friends at the Sustainable Soils Alliance. This pointed to an article which discussed some of these new studies that have been undertaken and are looking at soil properties and in particular the role of soil carbon. Now, humus has been a keystone in soil science for centuries and it's kind of always been relied on as really underpinning all the activity and everything that goes on in the soil because it's an incredibly stable substance made up of long strings of complex carbons, and as such it lasts in the soil for centuries or possibly longer. Or do they? The general gist is that even the most complex carbon can actually be broken down by soil microbes. And this means even the most complex, even the most stable ones, such as what are found in humus. And this study goes one step further and in fact says that soils are probably emitting more carbon than we think and are unable to sequester quite the volume of carbon that we have projected or modelled them to have. One of the reasons for this change in thinking in things like humus, which have been basically pretty stagnant and have remained the same, the ideas around it have pretty much been unfixed for almost 200 years, is the technology that's actually being used to investigate and look into soil. And no longer do we need to remove things and pull them apart from the soil to look at them, but we can actually look at them in situ. And as far as humus is concerned, it was thought that it was so stable and a very tiny fraction of it was ever consumed by soil microbes. And actually what these scientists in this article have found is that soil microbes are able to consume large volumes of varying types of carbon actually a lot quicker than we thought. So these microbes do in fact consume the long complex chains of carbon that are very difficult to break down, or so we thought, the recalcitrant carbon, and they emit this into the atmosphere as CO2. These new ideas do in fact throw lots of things into debate, such as our tillage practices and the move into min-till or no-till or no-dig. Actually, these activities could only be serving to redistribute the position of carbon in the soil, dragging it up from the depths to the surface and then holding it in the upper layer and not replenishing what was previously held at greater depth. Tying up carbon in the soil with plants has also been a widely adopted practice, and in fact another stream of research being carried out by the Salk Institute is looking at precisely this. They are looking at specific genetics in particular plants that excrete a substance called suberin, which could be used to lock down carbon in the soil and hold on to it for centuries even, thereby sequestering much more carbon into soil as a byproduct of growing these particular plants. In fact, Jeff Bezos from Amazon has even contributed over $300 million to this particular research as part of his own environmental kind of charitable organization. So this substance that these particular plants give out into the soil is a carbon compound called suberin, and the issue with that is it's made of carbon, and how that kind of fits with this new research. Well, all carbon, it doesn't matter whether it's this recalcitrant, hard to break down carbon or not, all carbon can in fact be broken down much quicker than previously thought. So actually that almost undermines this research that the Salk Institute are doing with these particular plants. So where is all of this going? Well, no one's particularly sure. The stable, unstale carbon model is rapidly being replaced by the soil continuum model, that carbon, like the rest of soil, obeys a cycle and it's dynamic. It changes all the time, but it's really only the early stages of this soil continuum model. and no one's particularly sure which direction it's going to go. But what does this mean to you with your plants, crops, vegetables and food that you're growing and diligently looking after the soil? Well, there's a few things I think that you can take away from it, and the first is starting to adopt this soil continuum model yourself and think of carbon as not a process that you complete. It's a dynamic process. It's changing all the time, and as you're doing things you will need to replace it. So the only way you can be sure what you have is testing your soil, looking at soil organic matter levels, maybe drilling down even further into soil carbon levels, doing that periodically as you grow different things, different seasons, across different years. One of the things I'm big into is helping people boost soil microbiology to grow better plants and produce better food. And that's fantastic, but with this new research, obviously if you're boosting your levels and activity of soil microbiology, you could in fact be helping to consume carbon at a greater throughput. So you need to be very mindful of that and think of carbon in terms of a cycle that will periodically need replenishment at the correct time. So if you're working at a microbiological level, growing things naturally, boosting soil life, chances are you might need to add organic matter back to your soil sooner than you think you do if you're doing a half decent job of that. And I do maintain one of the very best things you could be doing is adding the best quality organic matter to your soil that you have available, and not just one type, different types as well. Lots of sources of ingredients at different stages of decomposition, mixed up, recomposted together and applied to your soil at the right time. There are some other studies that exist out there as well, looking at using other plants to deposit carbon at much lower levels within the soil, so getting things from the topsoil and placing carbon back down in the almost subsoil kind of regions. But what you can take from this is growing a more diverse range of crops, extend your rotation and change periodically what you are actually growing. All of that will help shake up the microbiological communities in your soil and also feed on different parts of organic matter as a process. So consume organic matter in your soil, consume the carbon in a far more balanced way. I think extending a crop rotation and periodically adding organic matter could be particularly useful if you are playing around with different tillage methods such as no dig. So there you go everyone, that wraps things up for this video. I hope you enjoyed it. If you've got any questions or comments, stick them underneath this video. I'd love it if you hit like or gave us a thumbs up if you found it useful, and consider maybe following us and you'll be notified when I put out more videos like this in the future.